Hi, in this video we're going to look at changing the denominator of a fraction or changing the denominator of a rational expression. So why? Let's take a look at uh, an intuitive example. An intuitive example is one that we already know but maybe we take for granted. So if I take 1/2 and I add to it 1/4, I believe that most of us are comfortable with the idea that that is 3/4. But if you look at the problem, you can't simply add the ones or add the twos and the 2 and the 4. That doesn't get you to 3/4. What really happens is you have to change the whole problem into remembering that 1/2 is really the same as 2/4. If you do that, now the denominators match. And so we say these are common denominators. Oops, if I could, let me correct that. Denom in. Once the fractions have the same denominator, then we can add. And all we do is just add the numerators, the denominator stays the same. And so that is how you get 1/2 plus 1/4 to get 3/4. Now, let's take a look at just a bit more challenging problem and see if we can understand how this works. And now, in order to do this, we're going to do a little bit more work first. And this might seem a bit trivial, but bear with me. For example, if I ask you, what is 1 times 5? You would simply say, oh, well, that's 5. What if I switched the order and I said, well, what's 5 times 1? And again, most of us are comfortable with the commutative property of multiplication, meaning that you can switch the order and the result stays the same. That's, again, 5. Now, what if I change the number? What if I took 3 times 1? Well, the answer is simply 3. Notice that multiplying by 1, so multiplying by 1, I should be correct, multiplying by 1 does not change the other number. The other number. That's why we don't worry about a greatest common factor of 1, because nothing changes. Now, let's try one more thing. What if I take something like 5 divided by 5? If I asked you to simplify that, you would say, well, 5 divided by 5, that's just 1. What if I ask you, well, what's 3 divided by 3? And again, you would say, well, that's just 1. All right, let's try this. What if I asked you, what is 3/4 times 5/5? Now, there's actually two answers. The first one is you could very simply say, well, that 3/4 times 5/5 that's the same as 3/4 times 1. And we know that 1 doesn't change the other number, so notice that nothing's changed. It's still 3/4. So this is the first route. But what if we need to change? What if we need change? Well, let's take a look at what happens then. Then, what if I take 3/4 again, and I multiply it by 5/5, but I don't turn 5/5 into 1? That's 3 times 5, and that gives me 15. 4 times 5 is 20. In other words, 15/20 is another form of 3/4. Or, when we look at the problem up above, 2/4 is another form of 1/2. They're the same number, but now you might think of 15/20 as 3/4 in disguise. Now, so let me make a note of what we just did. Here's our summary, is that multiplying by 1 does not change the value, but with fractions, it can change the appearance. That's what we need to take a look at today. So let's try, I have a few examples here for you. Let's write, here's our first one. Write 1/6 with a denominator of 30. All problems begin with factors. You have to do that. Notice that 6 factors into 6 is 2 times 3. Let's take 30. 30, let's see. Well, there's a 2 in it. I could factor it into 2 times 15. And then I could go even further because 15 gives me 3 times 5. Now, this is where things get interesting. Notice this. The 6, they common, we'll say this. Or let me write it this way. Both have, this is what we have. We have this, the 2 and the 3. These all match. This matches with this. But to get the 6 into a 30, we need 5. So I have to take a 6 and multiply it by a 5. So here's how we do it. I'm going to set it up this way because I think it really is a clean way to approach it each time. And it's nice to have just consistent approaches that work for all the applications, and this one does. So I write 1/6 times, and I put a line here because we're going to figure out what to put in the numerator and what to put in the denominator here in a moment. We know that we need to end with a 30. So end, this is my begin, this is where I end. Now we just said that to turn a 6 to a 30, we need a 5. But wait a minute. I need something in the numerator. What do I need? I need the same thing. Because recall that 5/5 is just another way to write the number 1. So what we're going to do now is we're going to change the appearance of 1/6, but we're not going to change its value. Now I multiply it, 1 times 5, and I get 5. 6 times 5, and I get 30. Okay, let's try this. Write 3 over 2b with a denominator of 12ab. Wow, this could be a big one. So it all begins with the factors again. So the 2b, the only 2 is prime, so we can't factor 2 anymore, and b is done. So this is all the factors of 2b. Now, let's take a look at 12ab. I have a feeling that might turn into a bit more. Well, let's see. 12 has a 2 in it. That's 2 times 6, and I still have the ab. And I could break it up again. That's 2 times 6 is 2 times 3, and an A and a B. Now look at this. This is what we have. We have a 2 and we have the B. So now what we need to change 2B to 12AB is we need the other pieces. Well, the other pieces are these right here. The other pieces that we need are the 2, the 3, and the A. So we need 2 times 3 times A, and 2 times 3 times A is more simply 6A. So with that, I think we can now proceed. I'd set it up the same way again. I'd write my beginning fraction, which is 3 over 2b times, we're going to have some fraction in here, and we're going to end with a new fraction that has a denominator of 12ab. We know what we need, that's the 6a. And the 6a then goes into both positions. 6a goes in the numerator, 6a goes in the denominator, and the reason we can do that is that 6a divided by 6a is just the number 1. 1 doesn't change the value, but in this case, we're using it to change the appearance. So 3 times 6a, that's 18a, and 2b times 6a is 12ab. Okay, now, let's try another example here. We're going to write x over x minus 4 with the denominator of x squared minus 6x plus 8. Okay, here we go. The first thing again is we always look at factors. Well, x minus 4 is a binomial and it is factored. So there's nothing more that we can do there. Well, we look at our next piece. Our end goal is x squared minus 6x plus 8. Look at this. Well, what we can do is we can play the game. The top spot is 1 times 8. The bottom spot is the minus 6. It gives us answers of minus 4 and minus 2. So I take and I rewrite x squared minus 4x minus 2x plus 8. Notice I have a common factor of x in my first two terms, so I have x times x minus 4. My common factor now, I'm going to try a minus 2, so that's going to be an x. That'll change the positive 8 to a negative 4. That creates a greatest common factor of x minus 4 times x minus 2. Notice this. Again, we already have the x minus 4. We need the x minus 2. So now that we work the exact same way. So I'm going to write this as x minus 4 times our fraction. It's going to give us, and we're going to take a look at two different things. We can write this, we know our end goal is x minus 4 times x minus 2 in its factored form. And so now what we need, that creates my numerator and my denominator down here. So I have x minus 2, x minus 2. So I could just write this as x times x minus 2, or I could go and multiply this through, and I could say x times x is x squared, x times minus 2 is minus 2x. And if you multiply the parentheses out, well, we know the result. The result is where we began. X squared minus 6x plus 8. Okay. I know this has gotten a bit long, but this one's last example is kind of sneaky, and I think sometimes just hearing it makes it a lot more clear. So here's our last example. Write 2, oh no, let's not do 2, let's do 3. 3 over 2 minus x with a denominator of x minus 2. Okay, so remember our goal is always to factor first. Well, 2 minus x in one way, since it is factored. However, you could always factor from it. Let's try a -1. If I factor out a -1, the positive 2 becomes a -2. The negative x becomes a positive x. And because we can switch the order in addition, I could think of this as -1 times x minus 2. In other words, the fraction already has the desired end goal, end denominator. So let's see how this works. This is 3 over 2 minus x. That's where we begin. Now, let's use our end result here. Use this, so this becomes 3 over -1 times x minus 2. Now, in a couple videos prior, we said that the negative sign can either be left in the bottom, it can be moved to the numerator, or it can be moved out in front. And all three ways of writing it are exactly the same. We don't want to leave it in the denominator because our goal is to have an x minus 2 by itself, not a 2 minus x or an x minus 2 with something else. So I can write this as, I can move the -1, let's do it this way, I can move the -1 up here and write that. So I could write this as -1 times 3 over x minus 2. And -1 times 3, that's just -3. And you don't need to have the parentheses over x minus 2. Or the last way you could write it is just to put the negative out in front all by itself. And then you could write this as 3 over x minus 2. And that is how you change the denominator of a fraction or a rational expression. Thanks for watching.